Power of a product rule of exponents. If n is a positive integer and a and b are real numbers, then a times b to the n equals a to the n times b to the n. This says if you have a product, which is multiplication, raised to an exponent, then each factor of your product gets that exponent. A gets that exponent, and b gets that exponent, and they're still being multiplied together. For example, 2 times 3 to the second power, well, we could just multiply 2 times 3 because that's possible to get 6 squared, which we know is 36. But if we use this rule, then that first factor of 2 gets that power. And that's multiplied by the second factor, 3, that also gets that power. So 2 squared is 4 times 3 squared, which is 9, and 4 times 9 equals 36. So you see how that product to a power rule works there. Let's use that rule to simplify these expressions. Our first example, 5x squared y to the third power. So each factor gets that third power. 5 to the third times x squared to the third times y to the third. So 5 to the third power is 5 times 5 times 5. That's 125. X to the second to the third, that's the power rule, which says we multiply those powers. And y to the third. So that simplifies our expression there. For our next example, we've got a product. There's multiplication raised to an exponent. So each factor gets that exponent. It's kind of confusing, I think, what the first factor is because it's just a negative. But remember, if there's no number in front of your variable, what do we assume that number is? A 1. So that first factor is negative 1. That gets the power of 6. Times the second factor, x. That gets the power of 6, times that third factor, y to the fourth, that gets that power of 6. Okay, so we want to evaluate the expression here, negative 1 to the sixth power. Negative 1 to the sixth, if you multiply 1 6 times, it's still going to be 1, and 6 negatives will be positive. So positive 1, x to the sixth, and then y to the fourth to the sixth is the power rule. 4 times 6 is 24. So that's just x to the sixth, y to the 24. Our third example, we've got another product inside. That's all multiplication. So let's start with our first factor. Negative 5 gets this power. Our second factor, x to the third, gets that power. Our third factor, y squared, gets that power. And that last factor, z to the fourth, gets that power. Let's start simplifying. So negative 5 times negative 5, that's 25. Our base x is a power rule here, 3 times 2. Base y, power rule, that's 4. And base z, power rule, 4 times 2 is 8. So that is our simplified expression. Power of a quotient rule of exponents. If n is a positive integer and a and b are real numbers, then a over b to the nth power equals a to the n over b to the n. What this does is if you have a quotient, which means division, raised to an exponent, then each part of the quotient gets that exponent. So the numerator gets that exponent, and the denominator gets that exponent. Okay, for example, if you have 2/3 raised to the second power, we know that that's 2/3 times 2/3, which is 4/9. If we use this rule, then we give the numerator the exponent of 2, and we give the denominator the exponent of 2. And then you simplify. 2 squared is 4, 3 squared is 9, and you see how that's the same answer. So that's how the quotient rule works. Let's use the quotient rule to simplify some exponential expressions here. Our first example, p over 4 to the fourth power. So if we use the quotient rule, then the numerator gets the fourth power, and the denominator gets that fourth power. So p to the fourth we cannot simplify, but 4 to the fourth we can multiply 4 times 4 times 4 times 4. That base 4 times, and that is 256. So that simplifies our expression there. In the second example, we have a quotient to an exponent, so that means that each part of the numerator gets that exponent, and each part of the denominator gets that exponent. So then we have to use the product to a power rule, because in the numerator we have a product. We have 2 to the fourth power times x to the fourth power. Each part of the product gets that power. Same thing in the denominator. We have 3 that gets that power and y to the fifth that gets that power. So in the numerator, 2 to the fourth is 16, and x to the fourth is that power rule. 4 times 4 is 16. In the denominator, 3 to the fourth is 81, and y to the fifth to the fourth is the power rule. 5 times 4 is 20. If we could divide any factors, we would simplify, but that's as simple as it gets.